Welcome to this practical IoT video presented by Axeta. I'm Alexis Demers, an IoT software engineer working at Axeta, and I'll be presenting to you two tools today which are widely used in the embedded Linux domain, which are on one side Yocto, and on the other side Buildroot. So let me start by adding some context here. Let's say you're a CTO from any little startup that plans to deploy some technological devices, some little devices which are going to transfer data to the cloud or are going to control some motors and everything. You may also be any engineer from any big company that is planning to develop a new product in this kind of space. And at some point, you'll have some software to develop, of course, to connect to the cloud or to do any of the controls you want it to do. And you may think about using a Linux OS on your device. So of course it will imply some stuff over the hardware design of your device, but once you're over that, you'll have to decide at some point which OS, which distribution, or which tools I should use with those devices. Because yes, Linux provides so many open source libraries and open source software that will help your software team to go faster in the development. But the choice of the OS that is in the background has some big impact on the ability to deliver faster and the ability to develop correctly your application. So you may think about using a generic Ubuntu distribution, like an ISO file, for example, an image file you'll flash directly on your device, and that's it. But let me tell you now that this is probably not what you want. This is a whole subject, but in a few words, what you won't get out of a generic distribution is some kind of reliable package versions, reliable updates for that, and you'll get risk constrained on deploying for a lot of embedded devices. Generic distributions aren't made for large fleet deployments with large devices that all run the same software, basically. That's where our tools comes in. You're probably evaluating right now to use either Yocto or Buildroot to generate a custom Linux OS. It's custom in the sense that it allows you to package many libraries that you need and with fixed versions into one reliable image which you can deploy to your fleet of devices. There are other tools you could evaluate, but we will concentrate today on those tools which are widely used on the market. Those tools have the objective to facilitate the build of those Linux images, because doing it from scratch is very non-time efficient, if I could say. And first, let's talk about Yocto. So Yocto is born of an open source effort, which is the Open Embedded community. Yocto basically adds the layer called Pokey. Maybe you know it if you started to look around in Yocto. And Pokey provides many examples, many startup stuff, many foundations for building your own Linux images, so it facilitates that integration. And since Yocto and Open Embedded were integrated together, it became widely used, so you have a huge bunch of software of files which you can reuse for your design. I'll show you a link right here in the video where you can find the list of layers that you can reuse on your project. Because yes, Yocto is based on a layer functionality which facilitates reuse of different software parts and facilitates compiling for multiple platforms some amount of common software. So if you look into the layer index of Open Embedded, you can see everything that you can integrate easily in your own Linux images. So you'll quite quickly see that Yocto provides so many stuff that there is no need of redoing that all from scratch. What is provided there is awesome and will, of course, accelerate your development of your Linux image. That leads me to say that Yocto is a tool to build from scratch a Linux image, a Linux distribution. When I say from scratch, it means that it will take your PC's compiler, so GCC for example, to compile even the GCC cross compiler for your target device or target Linux device. It's probably ARM, so that's probably why you're using a cross compiler. Most of the time embedded Linux devices are using ARM processors, so that's why I say this. So it will compile the cross compiler, even it, and all the basic libraries, so the libc, any shell you need, any standard libraries you need will compile them from the cross compiler and then compile all the upper layers libraries up to your application. Even Yocto is able to build your application reliably to generate at the end a reproducible image, which is very interesting in that kind of platform of infrastructure. It allows to generate it very reliably so that every time you build the image, you get the same output at the end. Yocto is also a lot aimed at managing multiple hardware in the same code base. I just said a little link to that before. If you have multiple flavors of the same hardware, almost the same hardware, but not running exactly the same application, not needing exactly the same libraries or executable, Yocto is very efficient to manage all of that in one single repository with the layer functionality. Yocto allows to select which layer to use in which situation, and it also allows to build many images for many devices in one bunch and sharing all of the parts that were compiled between all of the images, the Linux images that needs them. Yocto development is based on metadata files. It's called the bitbake files. We have recipes, we have layer configuration files, we have append files, many other metadata files that are interpreted by the tool which is called bitbake. I'll just provide a link to bitbake right here. Bitbake is the tool developed by the Open Embedded community, which was initially used by Open Embedded only, but it is in Yocto by fact. So all of those files are quite complex when you address it at first, but it allows to define how your system is going to be built software by software. So there is a recipe file, a metadata file for building your kernel, metadata file for building your application, as I was saying earlier, and some configuration files for generating your images at the end. And that's most of it. Let's now talk about Buildroot. Buildroot is born of around the UCLibc library development. I don't know if you know about this. UCLibc is a subvariant of libc for small devices. So it grew up from around the development of that, but now it's separated from it. And this tool, just like Yocto, is made to build from scratch a Linux OS, a Linux BSP, Linux image for any embedded devices. So it does, just like Yocto, use your host compiler to generate their cross compiler, and then to generate the basic libraries and the upper libraries, and even your application too. The main difference is that Buildroot is using the standard Makefiles process to compile, so you'll find in the Buildroot main tree, which I'll just paste the link here, that there are Makefiles everywhere. So if you're already familiar with Makefiles, you may be able to look around at this code base a bit quite more easily than what you could do in Yocto. So all of the Makefiles are splitted into packages folder and into a BSP folder, which allows the system to select the correct software, compile it, integrate it into an image, select another software, compile it, integrate it into an image, in a similar way than that any Makefile project could do. You'll quickly see that Buildroot is aimed at simplicity. I've pasted you the link to the Buildroot codebase, and it's almost all what you need to see to know what's present in Buildroot. Note that there are other external kind of layers like Yocto, but external repositories that you can integrate with Buildroot, which we call externals, which can allow to extend the list of available packages. If you look in the link, if you go into the packages folder, you'll see what's available. I'm telling you that you can find more than that in some external kind of layers. I have an example for the AT91 processor here, which provides you some more libraries that can be used for the AT91 processor, but there are other examples. But at the end, you can even say there that Buildroot is aimed at simplicity. It's easier to address the project than what Yocto is at first. Note that Buildroot offer kind of limited support for multi-platform development. So if you have multiple hardware with different flavors, different parts that are different, and the requirements for the applications that are different, Buildroot supports developing with that kind of requirement, but it's a bit less supported than Yocto. Let's now talk about some pros and cons of Yocto. We will build a little bullet list here with the main pros and cons that I can think about right now. First one is that it's widely supported. There is a wide open source community support, very active development, and the framework is very fast growing. You have 3 releases a year for Yocto, and every year almost they do some breaking changes in the framework because they add some cool features. It's also provides libraries with almost the latest versions, almost always up to date. Of course, for embedded device, we don't want the latest cutting edge software. We want some stability at some point. But Yocto follows that very carefully. And second point is that Yocto supports as well very little OS and even very big OS. You could generate a complete OS for your personal computer if you want. You have some recipes to build Chromium if you want. You have some recipes to build Kubernetes if you want to host a Kubernetes server on your embedded device. So the possibilities are large. As a third point, there is a complete support or very interesting support for package management systems. With Yocto, you can generate Debian files as output in addition to the image files. You can generate IPK files, RPM files if you want, and you can use that output to directly generate a package feed on the cloud and allow any device to do an apt-get update and download the latest version of software if it's interesting for you. Note that Yocto also has powerful caching mechanism. I say powerful caching mechanism because it's very intelligent in the way that if you modify some software in your code base, you don't have to rebuild all of the Linux image that you've built before. Yocto knows how to rebuild exactly the minimum packages it needs to regenerate the image reliably at the end. Yocto offers mirroring, very powerful mirroring to speed up the builds with some shared caching. We were talking about the shared state cache if you go around that. The shared state cache allows to publish the cache of a build to many developers so that anyone doesn't need to rebuild all the image at all times. Everything is shared on a common server. And as I just said before, all of these provides a lot of reliability for output images and output packages in Yocto. And one last point I may address here is one big pro is that it's optimized for big teams working in the framework. So as I said, with mirroring and cache, of course, but with the extensible SDK, if you want to look around into that, and even the standard SDK, it's very easy to generate a software kit for application developers to work in parallel with people that work in the BSP, in the OS, in the Yocto framework itself, and be efficient and share code very efficiently. If we now talk about cons of Yocto, the first con I can think is, of course, the steep learning curve of Yocto framework. For any newbie going into the framework for the first time, he will probably be lost trying to find how to modify a package, how to modify some software or anything. I said very steep learning curve, but I could even say an extremely steep learning curve. There's a huge amount of time that is required for a newbie to start developing into that, so that can be a showstopper for any company trying to use Yocto, of course. And that leads also to the second con, which is, I've just said before that Yocto supports very well very little OS, so very little Linux images, as well as very large Linux images. But for any newcomer into Yocto, it could look very difficult to generate a little image, a very little Linux image. But it's possible, but without the knowledge on how the Yocto works in itself, at the end you'll probably get out with some big image. You expected something of about 50 megabytes as output image, and you get something like 300 megabytes, and you don't know why it's like that. And that requires often a lot of knowledge of the Yocto framework to optimize that out. Back to Buildroot now. We'll expose a bullet point list of pros of Buildroot now. First, Buildroot has fast growing development too. Far from what Yocto provides, but it's kind of good. As of today, they're releasing many releases a year, so it's interesting in that sense too. Buildroot has excellent support for small OS. If I can relate to what I was telling you about Yocto last time, Buildroot will probably give you a smaller image at the output. So if your target is having a small Linux image at the end, Buildroot will probably lead you to that more easily, because at its foundation, Buildroot generates smaller image without much configurations. Buildroot has the best time to market. As I said, it's using Makefiles, it's standard, so it's easier to lead to something that works. And the learning curve is smoother, definitely smoother. And then, the cons of Buildroot are, first one I can think is, it doesn't support well very big OS. Very big images, so if you're trying to integrate Chromium, as I was telling before, with Yocto it's kind of easy. With Buildroot, it's less evident, because those kind of big packages that are uncommon to embedded devices are usually not provided out of the box. So you'd have to redo that all from by yourself. And as a second point, there's no real package management support. So what you get out of Buildroot is a Linux image, but no package, no Debian files or something like that. You'll get only an image that is ready to be flashed on your device on an SD card or anything. But it's not thought for deploying for personal computers, for example. And third, caching mechanisms for Buildroot are kind of limited. You'll probably often have to rebuild all the image, all the framework many times in a day, because you're doing some changes and you're not sure that Buildroot took the changes correctly. So having a straightforward development flow is less evident. But a trade-off is that usually the build from scratch for Buildroot is a bit faster, so that can compensate in some way. We're already at the end of our video, so as a conclusion I'll tell you why should you choose one tool or why should you choose the other. For Yocto, first, choose Yocto if you plan on developing a potentially big OS. You plan to integrate Chromium as a web browser on your device, you plan to have a Java runtime environment, choose Yocto in those cases. Also choose Yocto if you expect a long-lived project with active feature development. So for the next 5 years, you'll be doing like 5 or 6 releases a year with some features for your customers. In this case, choose Yocto too. And then third, you plan on having multiple hardware platforms with some hardware differences, but they will all share the same some common code there. Yocto will help you with that too, where Buildroot may not help you that much. And then, choose Buildroot for one main reason, if you want the best time to market, actually. With Buildroot, you'll definitely get something working out of the box a lot faster than Yocto. So if you have a little team, you have a little resources to develop your image, you don't have any specialist in Yocto, then choose Buildroot, you'll get something out of it faster. Of course, if one of the points for Yocto are not valid for you, Buildroot can be valid for you, so go there if you want some fast time to market. So thank you everyone, and if you like those kind of videos, please subscribe.